So we're going to now go into the types of connective tissue. And there's actually 11 types of connective. There was only 7 types of epithelial, so there's a little more here. So I'm going to break this into 2 separate lectures, so it's not too much. So we'll do the first handful, and then we'll come back with a second lecture. So as I said, there's 11 types of connective tissue. And the reason why there's so many different types is because there's a lot of different jobs of connective tissue. Epithelial tissue was all very similar to each other. Connective, not so much. So let's get started. The first type of connective tissue is one of the more common types, and that is going to be areolar tissue. And areolar tissue is very thin. It's very wispy. It looks almost like cotton. When you guys, if we hopefully get to do the dissection this year, all of your tissues are held together by this areolar tissue. So imagine this is the glue that holds you together, and it binds the skin to the organs that are underneath it. And they're going to be found underneath the epithelium. So remember how I talked about there's a basement membrane, and the basement membrane is always between the epithelium and the connective, and then the epithelial tissue gets its blood from the connective tissue. This is the tissue that supplies it. So areolar tissue is very there's not a lot to it. It's basically going to be fibroblasts, so the type of cell. So if you're filling in that chart, which I recommend, the type of cell found in areolar tissue is going to be a fibroblast. And those fibroblasts produce 2 types of fibers, elastin and collagen. So I know it's hard to see in this image. It's a little blurry, but you can see those little purple dots are the fibroblasts, and then these thicker pieces are going to be the collagen, and those thin squiggly lines are going to be the elastin. So this tissue actually holds on to water really well. So think of it as something that's there to provide water, because our cells need water, and also blood supply. It fills in the gaps in between tissue. So the job of your areolar tissue is to provide blood supply and water to the surrounding tissues. It binds things together, and it also protects them. So think of this as just like the glue that holds you together. So that's areolar. Not a whole lot to say about it. The second type of tissue that is connective tissue is adipose tissue. And adipose tissue you're all very familiar with because that's our fat, right? That's what fat actually is, our fat cells. So this is connective tissue, which is composed of fats. Where are you going to find this? You're going to find this all over your body, around your organs, in your joints, under your skin. That's everywhere that fat is. And fat has some very important jobs. One really important job is cushioning and protection. It surrounds your organs and protects them. You can have too much fat for sure, but we need fat. It has a really bad reputation actually in our society, and fat is very important. You know, there's excess, there's too much of anything is bad, right? But we do need a certain amount of fat. It's also there to provide insulation and keep us warm, and as you're probably aware, it's storage of sugar, right? So if you eat food and that glucose gets broken down and you don't use all of it, your body's going to store it as fat. So what are we looking at here? Well, the type of cell is actually a fibroblast, and it's made up, the cell's made up of fibroblast, and then it actually fills up with fat. So what are we looking at in this image here? So you can see there's some like thin lines. These are the cells. That little A is pointing to that's the nucleus, so that's the fibroblast. And then what ends up happening is that fat cell, just like a balloon, fills up with fat. So it starts off as just a little fibroblast, and then the more fat that it accumulates, the bigger the cell gets. Now this is something you might not have known. You are born with the same number of fat cells you're going to die with. You don't ever gain or lose fat cells. What happens is they fill up or they decrease in how much fat they hold. The only way to get rid of fat cells actually, and I do not recommend or support this at all, is liposuction. So in liposuction, they actually go in and they suck out your fat cells. That's the only way that you're going to be able to get rid of a fat cell. You can have it empty, you know, you can get rid of all that fat by having it shrink down to just a fibroblast size, but it'll never go away. So you'll never get rid of that fat cell. So this would be an example of a bunch of adipose cells that are full of fat. If this person were to lose fat, these cells would shrink down. So imagine your adipose cells as water balloons, but instead of being full of water, they're full of fat, and they could shrink down or get bigger depending on the size. So the job of your adipose is going to be protection, insulation, right? And also energy storage. Where are you going to find it? All over. So you could say your joints, around your organs, beneath your skin, and the cell type is going to be a fibroblast. We'll do a few more. Okay, the next one is called regular dense connective. Okay, and regular dense connective is going to be what makes up all of your ligaments and tendons. So these are very strong fibers. They are dense. They're called regular dense. They're called regular because they all run the same direction. So if you look at this image here, what you're seeing is regular dense tissue. These are packed in so tightly. These little flat lines are fibroblasts. So the cells that make up your regular dense tissue is going to be fibroblasts. So these are going to be fibroblasts. But the reason why they're packed in so tight is because this collagen is just jammed in there. So it's like a big stretch, not really stretchy, but strong collagen band, and it makes up your ligaments, which holds your bones together, and it makes up your tendons, which holds muscle to bone. And they all run in the same direction, and that's important because when you move your let's say I move my arm like this, right? So for example, if everybody takes their arm right now and straightens it out, I don't know if you can see what I'm doing here. You can feel your tendon. If you go like this, you'll feel your bicep tendon pop up. It is running in the same direction as your bicep. So when you flex your bicep, it pulls your forearm towards you, right? So that tendon is pulling it towards you. And the reason why it's able to do that is because these collagen fibers are all lined up in the same direction. There is also elastin, but there's more collagen than elastin. So what are you going to do to fill in your chart? The type of cell is going to be a fibroblast. That is true. What type of fibers? It's going to be collagen and elastin, but mainly collagen. These are very strong fibers. It is hard to rip a tendon or a ligament. Now, if you've ever done, I'm sure some of you have torn your ligaments, but if you've torn your ACL before, you've torn this. That's not easy to do. And you know how hard it is to heal. So I do want to talk about one more thing. These heal very slowly. You're much better off breaking a bone than you are ripping a tendon or a ligament. And the reason why is because of blood supply. You need blood to heal. Blood is required to heal something. That is why when you break a bone, it bruises really badly, but then it heals. It's bruising because there's blood there. In your dense connective tissue, there's a very poor blood supply. There's blood supply, but because these fibers are packed in so tight, the blood supply can't get in. So when you destroy one of these things, if you rip that tendon or you rip that ligament, it will heal, but it takes a very long time because of the fact that it doesn't have a good blood supply. So these are very strong fibers and they hold your body together. Your ligaments and tendons are made of them, but the reason why they don't heal very quickly is because they have a poor blood supply. So that is regular dense. We're going to do two more. The next one is irregular dense. Oops. An irregular dense, this is going to be just like regular dense, but instead of the fibers all running the same direction, they run all over the place. They run in all kinds of directions, and this is going to be called irregular dense because it's disorganized. And the reason why it's disorganized is this is found in your dermis of your skin. So if I were to draw your skin, what it would look like would be something like this, where you have a layer, right? And then you have your stratified squamous, which we talked about, right? So we have our stratified squamous up here, and that is epithelial tissue. And then we have our basement membrane right here, and then right below it we have something called the dermis. And the dermis is actually connective tissue. So this is your dermis here. And that is made up of irregular dense tissue. That is what provides the blood supply for your stratified squamous, right? The blood goes that way. And then this is dead up here actually, right? So that's dead tissue. Down here it's very much alive though. And by having it be irregular, by having that collagen run in all different directions, what that does is it allows for stretching in different directions. So for example, if you're sitting in your seat right now and you move around in your seat, what's going to happen is your skin's pulling lots of different directions. And what that very strong fiber underneath in that irregular pattern does is it allows you to stretch it in multiple directions without causing any damage. So what type of cell make it up? Fibroblasts. Just like before, it's made of fibroblasts. So far, everything's been made of a fibroblast. And then the fibers are going to be collagen and elastin. The only difference between irregular and regular dense tissue is where it's found, right? Regular is going to be in ligaments and tendons, and also the organization of those fibers. In regular, they're going to all be running the same direction. And what that does is it allows it to stretch and prevent ripping or tearing in one direction. Irregular, it's in a very disorganized pattern, and what that does is it lets it stretch in multiple directions. I'm going to stop this lecture here, and we're going to do another lecture on cartilage and bone. So this is a good stopping point.